So in this first example, it is asking us to find the sum of the measures of the interior angles of this polygon here. And just a reminder, we have a formula for this, right? Our formula for finding the sum of the interior angles, it has to do with triangles. It has to do with the fact that if we take this polygon here and we break it up into a bunch of triangles, if we pick one of the vertices, I'll pick this vertex here, I'll call it vertex A. I can draw diagonals, which are segments connecting opposite corners or non-consecutive corners. I can draw diagonals to all of the other corners that I can. And in doing so, you can see I've created a bunch of triangles. In fact, I've created 1, 2, 3, 4, 5, 6, 7. 7 different triangles by drawing all the diagonals from one of these vertices. And each of those triangles has 180 degrees for its interior angle sum. So if I just take that 180 and multiply it by 7, that should give me my total for the interior angles. I'm going to take 180 times 7, and then 180 times 7 is going to give me 1,260 degrees. Now, of course, the real question might be, do I really need to draw all these triangles, or is there a faster way to figure out that I'm going to be doing 180 times 7? And the answer, of course, is that there is. All I need to do is count how many sides I have on my polygon. In this case, I have 9 sides. And if I take that number of sides, take off 2, and then multiply by 180, that's how I'm going to figure out. That's maybe a shorter way rather than drawing all of these triangles. I can count the sides, subtract 2, multiply by 180, and that's going to give me my number, or my total for the interior angles. So again, I'd be doing 9 minus 2 times 180, and that 9 minus 2, that's where we get that 7 from. So in either case, we're doing 7 times 180. Now on the second question, this one's going to be really easy because this one's now asking for the sum of the measures of the exterior angles of my polygon. Same polygon I had before, so it's still got 9 sides going around here. Now we need to know what the sum is for the exterior angles. And the great thing about this is, if we remember, the exterior angles theorem says that no matter how many sides your polygon has, the sum of your exterior angles is always going to be 360 degrees. So our answer is just going to be 360. Doesn't matter that it has 9 sides. It could have had 3 sides. It could have had 10 sides. It could have had 27 sides. The sum of the exterior angles will always be 360. So that brings us to this third example, which is going to be maybe a little bit trickier. We have to find the value of the x and the y in my picture here. Now if I look at the x, I see that it is an exterior angle, but it's only one of them, so it's not going to be 360 because that's what all of them would add up to. And I'm not going to just be able to take 360 and divide by the number of sides that I have, because that would mean that I'm thinking that every one of the exterior angles in this picture would be congruent, but they're not necessarily congruent because this, each exterior angle kind of depends on what the interior angle is next to it. And all these interior angles seem different, so that tells me that if I look at, for instance, the exterior angle coming off of here and then the exterior angle coming off of here, that angle and that angle, those would not necessarily be the same. So I can kind of do two things here. I can either figure out y first and then subtract from 180 to find x, or I could try and find x first, subtract from 180 to find y. I think the method I'm going to use is I'm going to try and find y first. Y is an interior angle, and my polygon has 1, 2, 3, 4, 5, 6, 7 angles, which also means it has 7 sides. So my total interior angles, my total for the interior angles is going to be found by doing 7 minus 2 times 180, which is 5 times 180, which is going to be equal to 900 degrees. So I know that my total for all of these should be, all 7 of these should add up to 900. Well, now if I can just figure out what I have with these 6, I can figure out what that total is, figure out how much I'm missing to get to 900, and that missing number of degrees must be my angle y here. So the next thing I'm going to do is I'm going to take 135 plus 140 plus 150 plus 120 plus 135 plus another 120, and I'm going to figure out what that is equal to. And if I do a quick, I'm going to show you just kind of how I'm going to do this mentally. I'm going to notice that I have 1, 2, 3, 4, 5, 6 100s, right? So that gives me 600. And then I'm going to start adding together some of these other, the 600 accounts for like the 100 and the 135 and the 100 and 140 and the 100 and 150. So now I'm going to see what happens if I combine some of the other kind of the place values in all of these. So I notice that if I do 35 plus 40, that's going to give me a 75. 50 and 120 is going to give me another 70. 35 and 120, the 35 and the 20 is going to give me another 55. Now if I do 65 and 70, let's say we add those together. So that's going to be 145 plus 55. If I add the 145 to the 55, that's going to give me 200. So now I have 600 plus 200, which is going to finally give me 800. Now, of course, I could have just typed those into my calculator, and if I wanted to, I could have maybe gotten that 800 just as fast, maybe a little bit faster, who knows. But I know that all of these angles now add up to 800 degrees, and so the measure of angle y, or the measure of the y, is going to be 900 minus the 800, which is going to give me 100 for y. So the y is 100. Now the x, I know that x plus y needs to equal 180 because those two angles form a linear pair. So x plus 100 equals 180, and that means x must be 80. In my fourth example here, it wants me to find the measure of each of these exterior angles. I know they should all add up to 360, but that doesn't tell me what each one should be. But I notice that they're telling me something about each interior angle, and there's 5 of them. So let's think about this. We know that 5 minus 2 times 180 would be 3 times 180, which would be 540 degrees. That's what these 5 angles should add up to. So let's go ahead and set up an equation that adds all these together and sets it equal to 540. I'm going to need a little space to do this because I got several things I'm adding together. So I'm going to do x plus 15 plus 4x minus 10 plus 3x plus 10 plus 2x plus 5 plus 3x. All that equals 540. Now let's combine our like terms. How many x's do we have? We have 1 plus 4 would make 5, plus 3 would make 8, plus 2 would make 10, plus 3 would make 13. So I have 13 x's. Now let's go ahead and combine all the the constant terms, the terms without the x's. First of all, I'm going to notice that I have a minus 10 and a plus 10. Let's go ahead and cancel those out. And then that's going to leave me this 15 and this 5. So that's going to be plus 20, and that's going to end up equaling 540. Now I'm going to subtract 20 from each side. So 13x equals 520. And then I'm going to divide each side by 13. And that's going to give me, if I do that on my calculator real quick, 52 divided by 13, I believe that's going to give me 40. So now x is equal to 40. So now what I can do is I can go through each of these interior angles and I can substitute in my x to get what that actual angle measure is. So let's do that next. This angle, the one next to angle 1 here, is going to be 40 plus 15, which is 55 degrees. And then the one next to angle 2 is going to be 4 times 40 minus 10. So that's 160 minus 10, which is 150. The one next to angle 3 is going to be 120 plus 10. So that's going to be 130. The one next to angle 4 is going to be 80 plus 5. So that's 85. There, let's write that again down here a little bit neater, 85. And then the one next to angle 5 here is going to be just 120, 3 times 40. Okay, so now I can take each of these amounts and subtract from 180 to find angle 1, and then angle 2, and so on. So that's going to be my last step here. I'm going to go ahead and do 180 minus 55, which is going to give me 125. For angle 2, I'm going to do 180 minus 150, which is 30. For angle 3, it's going to be 180 minus 130, which is going to give me 50. Angle 4 is going to be 180 minus 85, which is going to give me 95. And angle 5 is going to be 180 minus 120, which is going to give me 60. Now, again, the nice thing about geometry is a lot of times after we get these answers, we can start looking at them and saying, does that seem like it can be correct? And in this case, what I'm going to do is I'm going to add all of these together and see if it comes out equaling 360 like it should. So that's the way I'm going to kind of check my answer. I'm going to take 125 plus 30 plus 50 plus 95 plus 60. And I'm going to see what that all adds up to. So that's going to be, let's see, I would have the 125 plus 30 is going to give me 155 plus 50 plus 95 plus 60. Now if I add these two together, that's going to be 205 plus 95 plus 60. That would give me 300. And then 300 plus 60, yeah, that gives me 360. So I feel pretty confident that these are going to be all of the angle measures for angles 1 through 5. Okay, so one more question here. It says the sum of the measures of the interior angles of a regular n-gon is 6,120 degrees. What is the measure of each interior angle? So first of all, we know that it's a regular n-gon, which means that all these interior angles are going to be the same. So if we could take this total number of degrees for the interior angles and divide by how many sides there are, or how many angles there are, that would give me my measure for each interior angle. So the real question is, how can we use this total and figure out how many sides it has? Well, I remember that to find that total, right, our total interior angle measurement is always equal to n minus 2 times 180. So now if I substitute in my 6,120 for that total, then I'm looking at that equaling n minus 2 times 180. So what we really need to figure out is how many 180s are there in 6,120. So what I'm going to do is I'm going to divide essentially both sides of this equation by 180. Now 6,108 or 6,120 divided by 180 is going to give me 34. So 34 is the number of sides minus 2, right? Because I just canceled out the 180 from that side. So now that means if I'd add 2 to both sides, the number of sides, oops, not 360, the number of sides in my triangle is, or I'm sorry, the number of sides in my shape is 36. So I have a 36-sided shape. But again, that's not my answer. That's just how many angles there are. If I want to know what the measure of each one is, remember what we said is we could take that total and divide by how many there are. So the next step we need to do is 6,120 and divide that by 36. And when we type that in our calculator, what we're going to get is 170. So each interior angle of this shape is going to be 170 degrees. If it had asked how many degrees each exterior angle is, we could have done that a couple ways. We could have found out the interior angle like we did, and then just subtract that from 180 to get 10. Or we could have said, well, if there's 36 of those, we could have possibly just done 360 divided by 36, because we would know that if we're looking at exterior angles, the total should be 360, and we figured out that there was 36 of them, and 360 divided by 36 would also have given us 10. That was just in case the question had asked about exterior angles instead of interior angles.